Have you ever wondered why Copernicus's heliocentric system made a colossal intellectual revolution? The great Polish scientist mathematically proved Earth's axial rotation and its orbital motion. It turns out that the looping planetary trajectories are a simple consequence of their mutual overtaking in orbits. This ingenious model established the true order of all celestial bodies for the first time.
For well over 1,000 years, the prevailing view of the cosmos was one of absolute certainty. Humanity stood at the center of everything. The sun, the moon, the planets, the entire sphere of stars, it all revolved around us. But then a single scholar, Nicolaus Copernicus, proposed a fundamentally different arrangement. His work wasn't merely a new theory. It was an intellectual earthquake that would permanently shift our place in the universe. So let's examine the structure of this revolutionary idea.
Here's our roadmap. We'll begin by setting the stage, looking at the ancient geocentric model that Copernicus was challenging. Then, we'll break down the fundamental postulates of his new heliocentric system. From there, we'll see how these principles allowed him to construct a new and correct architecture for the solar system. We'll then analyze how this new model elegantly solved astronomical puzzles that had perplexed observers for centuries. And finally, we'll consider the profound legacy of what we now call the Copernican revolution. To appreciate the magnitude of Copernicus's work, you have to understand what he was up against. For about 14 centuries, European astronomy was dominated by the model of Claudius Ptolemy. It put a stationary, unmoving Earth right at the heart of the cosmos. This was, intuitively appealing and deeply embedded in the philosophical thought of the time. The problem was, to make it match observations, it had become incredibly complicated, requiring a whole system of circles rolling on other circles. It was into this long-established consensus that Nicolaus Copernicus introduced his radical alternative.
This is the key document on the revolutions of the heavenly spheres. His life's work was published in 1543, the very year he died. And this wasn't just a philosophical treatise. Copernicus laid out a rigorous mathematical framework for a sun-centered or heliocentric universe. This text was the scientific foundation for an entirely new astronomy.
So what is the heliocentric system at its core? Well, the name itself tells you everything you need to know. Helios, the Greek word for sun, is placed at the center. In this model, the Earth is demoted. It's no longer the fixed central stage for all cosmic events, but is instead just another planet, one of several, all in orbit around the sun. This was a complete inversion of the established worldview. So, how did Copernicus build this new model from the ground up? Well, like any good logical system, it starts with a few foundational assumptions, or what he called postulates. These are the axioms upon which his entire heliocentric universe is constructed. Let's examine them one by one. Okay, the first two postulates are absolute game changers. Number one, the sun, not the Earth, is the center. That's the big one. But number two is just as critical. The Earth is not stationary. It's a sphere that rotates on its own axis once every 24 hours. Think about what that means. The daily rising and setting of the sun, the moon, and all the stars is no longer the result of the entire cosmos wheeling around us. No, it's simply an apparent motion caused by our own planet's spin. Next, Copernicus argued that the Earth has a second motion. In addition to spinning, it also revolves around the sun in a large circle, completing one orbit per year. This is what explains the sun's apparent annual journey through the constellations of the zodiac. It's not the sun that's moving against the background stars, it's our vantage point that's changing. But you'll notice he wasn't a complete radical. He held fast to the ancient Greek philosophical ideal of perfect, uniform, circular motion. This assumption would turn out to be incorrect, but it was a bridge to the past he couldn't quite burn.
Now this is where it gets really clever. The next postulate deals with the relativity of motion. Copernicus realized that the bizarre, looping paths that planets sometimes trace in our sky, that retrograde motion, wasn't a real physical movement at all. He argued it was an optical illusion, created because we are observing other moving planets from our own moving platform, the Earth. And finally, he correctly defined the moon's role. It's a satellite orbiting the Earth, carried along with us as we journey around the sun. Once these postulates were in place, Copernicus was able to do something truly remarkable, something that was simply impossible within the old Ptolemaic system. For the first time, he could logically deduce the correct order of the planets and even their relative distances from the sun. He essentially drew the first correct map of the solar system. His method was based on straightforward observation. He noted, as had astronomers for centuries, that Mercury and Venus are only ever seen near the sun, in the morning or evening sky. They never appear high in the sky at midnight. This simple fact means their orbits must lie inside the Earth's orbit. Conversely, Mars, Jupiter, and Saturn can be seen at midnight, in a position directly opposite the Sun in our sky. This is called opposition, and it's only possible if their orbits are outside of Earth's.
And then he refined the order with more subtle logic. He observed that Venus can stray farther from the Sun in the sky than Mercury can. This maximum elongation corresponds to the size of its orbit, so Venus must be farther from the Sun than Mercury. For the outer planets, he looked at their apparent speeds. Mars moves the fastest against the backdrop of stars, Jupiter is slower, and Saturn is the slowest of all. He correctly inferred that this speed is a direct consequence of their distance. The closer the planet, the faster it appears to move.
Let's just pause on that for a moment. This was a monumental breakthrough. For the first time in human history, someone had laid out the correct architecture of our planetary system. The geocentric model had no way of doing this. Its ordering of the planets was based more on tradition than on observation. Copernicus gave us the blueprint. Let's just pause on that for a moment. This was a monumental breakthrough. For the first time in human history, someone had laid out the correct architecture of our planetary system. The geocentric model had no way of doing this. Its ordering of the planets was based more on tradition than on observation. Copernicus gave us the blueprint.
We now come to the real predictive and explanatory power of the Copernican system,
The old Ptolemaic model had to invent a whole series of complex devices, epicycles, deference, equants, all just to get the planets to move correctly. It was a cumbersome, patchwork system. Copernicus showed that with a sun-centered model, much of this complexity simply disappears.
Let's take the sun's yearly motion. In the old model, the sun physically traveled a path around the Earth. Simple enough. But in the Copernican explanation, it's an effective perspective. The Earth orbits the sun. As we move from one side of our orbit to the other, our line of sight to the sun projects against different distant constellations. The sun's apparent motion is just a reflection of our own real motion. It's so much more elegant.
But what about the biggest puzzle of all? Retrograde motion. This is the observation that planets, especially Mars, will occasionally slow down, stop, move backward against the stars for a few months, and then resume their forward motion. How on earth could a simple sun-centered system explain that bizarre celestial dance?
The explanation is a beautiful piece of orbital mechanics and perspective. Imagine Earth and Mars are cars on a racetrack. Earth is in the inner, faster lane. As we approach Mars from behind, it appears to be moving forward against the distant background, but as we catch up and overtake it, our line of sight changes. For the duration of the pass, from our moving perspective, Mars appears to drift backward against the very distant stars. It's not actually moving backward. It's an illusion, created by our own faster orbital motion.
And that's the key insight. The complicated physical machinery of epicycles in the Ptolemaic system was created to solve a problem that wasn't actually real. Retrograde motion wasn't a complex physical maneuver. It was simply an artifact of relative motion. The Copernican model solved it by reframing the problem entirely.
So let's conclude by looking at the broader impact of all this. The Copernican system was more than just a neater way to arrange the planets. It fundamentally altered our relationship with the cosmos and set science on a new trajectory. One where physical models were meant to describe reality, not just save appearances. This is really the heart of the matter. For many of his contemporaries, the Copernican model was seen as a useful fiction, a clever mathematical tool for calculating planetary positions, but not a description of how things actually are. But the true power of the idea and its revolutionary nature was the claim that no, this is a picture of physical reality. This is how the cosmos is actually built.
Now, of course, the model wasn't perfect. Copernicus was still a man of his time, and he couldn't shake the ancient Greek conviction that heavenly motion must be perfectly circular and uniform. This was the system's major flaw. Since planets actually move in ellipses, not circles, his model still needed some minor epicycles to work accurately, and its predictive power wasn't a dramatic improvement over Ptolemy's. That final piece of the puzzle would have to wait for Johannes Kepler and his laws of planetary motion.
And this leaves us with a fascinating final thought. Copernicus made the colossal leap of putting the sun at the center, yet he remained tied to the ancient and incorrect assumption of perfect circles. So what does this tell us about how science actually moves forward? It shows us that progress is rarely a single clean break from the past. It's often a messy process, a combination of revolutionary insight and inherited assumptions, where each new generation builds upon and corrects the work of the giants who came before.
Thank you, friends. Strive for understanding and become wiser. See you soon.